Hello everyone, and welcome to the SQL Beginners Level Workshop. My name is Alex, and I'm your instructor today. I'm also thrilled to be here with you. Just a brief introduction of myself. I have been working with data for about 6 years, and during this period, I have taken on roles as a data analyst, business analyst, and a data management consultant. In today's workshop, we're going to learn SQL from the very beginning. By that I mean if you have absolutely no knowledge of SQL and your goal is to learn SQL from the scratch and become proficient in SQL, then you are at the right place. Let's go through the content we're covering today. We start our day by talking about some of the importance of SQL. Then we dive right into the body of the course itself. So we talk about data, databases, and then database management systems. Then we talk about SQL itself. What exactly is SQL? Subsequently, we will explore some of the different data types in SQL. So we have the numeric, the string, and the date and time data types. Then we go into tables. I would introduce you to tables. What are tables used for? And then we talk about data definition language. We will look at some of the commands that falls under data definition language, DDL. So we have the create, the drop, and the alter commands. Then we dive into SQL constraints. We will look at the null and not null constraints as well as the default constraints. As we come close towards the end of our time today, I will give you some tips on things you may not be aware of about transitioning into a data-related field. And finally, I would provide you with resources that takes you beyond what you would learn today to you becoming an expert in SQL. Most of our time would be spent querying in SQL, and the plan is for you to code along with me. I will spend some time introducing and explaining certain concepts that you may possibly not know of, but other than that, we would be querying in SQL. When we think about analyzing data, there are certain steps or processes that is typically followed. First, we need to retrieve the data from a source location. Now, depending on how the data is generated, we may need to convert the data into a form that is compatible with the data destination. Subsequently, we need to store the data. Once we have securely stored the data, we can start manipulating the data to derive insights. And the next step would be to present our findings. We can achieve all of this using SQL. So why should anyone care about SQL? Well, first, I believe the fact that you are here means you are aware or have done your research on the importance of SQL. But let's go through some of the reasons you may want to become proficient in SQL. SQL is one of the most used languages for data analysis. You may not know this yet, but SQL is also quite easy to learn. Like anything, you just need to put in the time. Also, most data-driven companies use SQL. If data is at the center of what that business does, then in one form or shape, SQL would be part of their tools or be part of the language they use in analyzing their data. Also, if your goal is to dive into the field of data science, big data, you intend becoming a data analyst, business intelligence analyst, or a business analyst, or any data-related field, then the importance of knowing and learning and being proficient in SQL cannot be overemphasized. What is data? Data in its true form is an unorganized and unprocessed fact, and it could include numbers, images, sounds, characters, text, or videos. Unstructured data has little meaning to us. Data is typically derived from observations or measurements. And just to explain this further, imagine on a given day you stand at the corner of your street and you see people cycling on their bicycles. Now, these are just people going about doing their business and has little meaning or little or no meaning to you. But what if for a research purpose you need to find out the usage of bicycle lanes within your community? For this research purpose, you may want to record and observe the amount of people cycling on a given day, perhaps even a given time of the day in the morning, afternoon, or at night. You may also want to record peak times or low times. Now, the same people that were randomly cycling and add little or no meaning to you, now become a data source that you can observe, that you can measure and derive insights from. Data, when processed, becomes information we can read, understand, and use. Data is an unorganized and unprocessed fact and can include numbers, figures, images, characters, and is typically derived from observations or measurements. Next, what is a database? A database is an organized collection of data, typically stored electronically in a computer system. We already established that data could be numbers, could be text, could be colors. If we consider this box, what we have is a collection of data. So data is stored inside a database. So far, we know how to define data. We also know that a database is a collection of data, or a database is used to store data. But what is a database management system? Database management system is an application used to manipulate, retrieve, and manage data in a database. It is a system that interacts with the database. Let's look at this image. We have the database, but we also need to be able to retrieve data from the database. And that's really what the database management system does. One way to think about this is, assuming you want to find the cheapest ticket to travel to London, and you go to the Google web page and you type within the search bar, find the cheapest flight to London. That information that you just asked Google to supply you is stored in a database. In order for you to see that information on your screen, there is need for something to pull that information from the database where it's stored. And what pulls that information and presents it to you is the database management system. As you may imagine, there are different types of database management systems. However, for this workshop, we are going to use Microsoft SQL Server. You should have received a YouTube video with instructions on installing Microsoft SQL Server either on a Windows operating system or MacBook. I hope you were successfully installing it. To get a sense of those who will be coding along with me, if you were successful installing SQL Server and ready to code, please type in the chat, "Let's do this," just for me to get a sense of the number of people who are coding along. Now, if you are yet to install the application, you will still learn a lot from this workshop. Also, the recording of this workshop will be available on my YouTube channel, so kindly subscribe to the channel for easy access to the recording, as well as other SQL tutorial videos. Alright, so this is where we start querying in SQL, and to do that, the first thing we need is to launch Microsoft SQL Server. So I already have Microsoft SQL Server pinned to my taskbar for easy access. I would recommend you do that as well. If you're yet to do that, just click on the Start menu, and if you scroll all the way down to M, you should see Microsoft SQL Server Tools 18. When you click on the drop down, you would have Microsoft SQL Server Management Studio. If you click, and all you need to do, if you right click, you have the option to, if you click on more, you can pin it to your taskbar. For me, it says unpinned because it's already pinned. So just go ahead and launch Microsoft SQL Server. Once Microsoft SQL Server Management Studio launches, you should have the Connect to Server box show up. Right here, you have the server name. If for any reason you don't see your server name show up here, all you need to do is click the drop-down menu, click on Browse for More, and under the database engine, you should see the server name, so the database engine name. So once you select that, that's your server name. And next thing you want to do is connect to server. Once we connect to the server, we should have the Object Explorer on the left side of our Microsoft SQL Server Management Studio. And what we really would focus on is this databases folder. So under the databases folder, you should see two folders. We have the system databases and we have the database snapshots. If you click on the drop-down menu for the system databases, we have four different system databases. We have the master, model, MSDB, and TempDB. All these databases are used by SQL Server for the functioning of the server. Once we create our own database, it's going to be created below the database snapshot. Next, I would like you to click on New Query. And this is going to launch a query box, and this is where we write our SQL queries. The first thing I'd like us to do is, right here you see that I have the number 1, and this is called line number. In your case, because this is if this is the first time you are launching or using Microsoft SQL Server, you may not see this numbering. I'm going to show you how to add the numbering, then I'll explain to you why this is important. To add a number to the line, to add a line number, click on Tools, Options, and then you want to go to, Text Editor, and under Text Editor, click on Transact SQL, and click on General, and what you want to do is to check the line number box. Once you check that and click OK, the line number would appear. Now the purpose of the line number is, as you begin to write your SQL codes, you may have errors within your queries or within your codes. And typically, SQL Server would indicate the line number where the error lies. So by having a line number, it's easier for you to track wherever you have, wherever there's an error with your code. If you don't have a line number, you sort of would have to manually count that yourself. Okay, so that's why it is important to have the line number. The first query we are going to learn in SQL is how to create a database. The syntax to create a database is create database followed by the name of the database. Assuming we want to create a database that contains information about different restaurants in the city, all we need to do is we type create database followed by the name of that database for us, which will be restaurants. Say we want to create a database to store different information of computers. We can do the same thing by using the syntax create database followed by the name computers. Let's switch over to SQL Server. All right, so to create our first database, we type create followed by database, and then we want to type the name of the database for us, that will be restaurants. Now we end with a semicolon. Whenever we write query in SQL, we need to end the query with a semicolon. And what that does is it indicates to SQL Server that we are done with that line or with that particular query. Also, the two words create and database are what we call keywords in SQL. Keywords are reserved words or special words that SQL use internally for its own functions. Another thing you notice is that when you type SQL keywords, by default they are highlighted in blue. So you can see create database is by default highlighted in blue, and the word restaurant is in black because we chose that word. This is really just indicating to us that restaurants is not a keyword in SQL. Now, for us to execute or to finally create this database, we need to run this command. To do that, we have to highlight. You click down and you highlight, and all you need to do is click execute. Once we click execute, the command will be completed successfully, and then the database is created. Let's create another database to store information about computers. So the same thing, we have create followed by, so we have create database followed by the name of the database, for us will be computers. And all we need to do is execute to run that query. Now, for us to see the databases that we create, if we look under our databases folder, at the moment, we don't see the database that we created, the two databases that we created. All we need to do is click on the databases folder and click on the refresh icon. Once you do that, we can now see the two databases we created, computers and restaurants. Another thing I'd like to point your attention to is when I typed the keywords create database, you notice that I have those two words in uppercase. Now, the rule of thumb is whenever you type a keyword in SQL, that you type that in uppercase, and whenever you type words that that you choose that, well, essentially words that are not SQL keywords, like in our case, restaurants and computers, you write those in lowercase. I haven't said that it's not the query is not going to break if you type the keywords in lowercase. It's just more of a rule of thumb. So, for example, let's say we want to create another database, and let's just say we're going to call that database basketball. And when we execute, we can see that I'm going to refresh our databases, and we see that the database was created as well. Now, my recommendation to you would be to always use uppercase whenever you write SQL keywords, because again, that's the rule of thumb. That's the proper way to do it. Of course, yes, if you use lowercase, that works as well, but you're just learning. You definitely want to learn the proper way. All right. Alright, so you just wrote your first SQL query, and I'm sure that feels really nice and good job as well. The next step would be for us to select a specific database to work with. As you can imagine, we need to choose a specific database to work with because right now we already created 3 databases, and we also have the 4 system databases that by default comes with SQL Server. If we need to, manipulate our records or work with specific record, then we need to tell SQL Server which database those data or the records that we want to work with, what's the database that the data is contained inside. The syntax we use to select a specific database is we have the keyword use followed by the name of the database. So if we want to work with our restaurant database, we type use followed by the name restaurants. If we want to work with our computers database, we type use followed by computers. Before we select a specific database, I would like to point your attention to the top left corner of your SQL server. And right here, you see that it says master. And this box indicates the current database that we are inside of. So when this shows master, this is telling us that we are currently inside of the master database. Now, watch what happens once we choose to use a different database. So assuming we want to work with our computers database, we type use, which is the keyword, followed by the name of the database. In our case, will be computers. We end with a semicolon, and when we execute, immediately we see that the name changes to computers to indicate that we are currently inside of the computers database. If we switch back, let's say we switch to using basketball, execute, we see now we are inside of the basketball database, which means we'd have access to whatever is contained, or we can work with any data contained inside of the basketball database. So far, we know how to create a database. We know how to select a specific database to work with. What if we choose to delete a database? The syntax to delete a database is we use the keywords drop database followed by the name of the database. If we want to drop or delete the restaurants database, all we need to do is we type drop database followed by restaurants. The same way, drop database followed by computers. Assuming we want to drop the basketball database, now going by the syntax, all we need to do is type drop database followed by the name of the database, which is basketball. However, there is something I need to point out to you. You cannot delete a database while you are still working inside of that database. So at the moment, we are currently inside of the basketball database. So we cannot delete the basketball database. And let's try and do that and see what happens. So we type the keywords drop database followed by the name of the database, which is basketball. When we execute, we get an error, and the error says cannot drop basketball because it is currently in use. So for us to drop basketball, we first need to be outside. We have to be in another database. It could be a master database. It doesn't really matter. And what we can do is we can just re-execute computers, so use computers, and that's just going to take us inside of the computers database. And now when we run the command to drop basketball, we see that the command was completed successfully. Now, when we look at our folder, we still see the basketball we still see the basketball database that we created. And all we need to do is just refresh. And once we refresh our databases, we see now that basketball database is no longer there because it has been deleted. Let's go ahead and delete our restaurants database. When we execute, command completed successfully, and when we refresh, now we only have our computers database left. Why don't we go ahead and delete the last database, which is computers? Now, because we are currently inside of the computers database, we need to switch our database. So we can either go into one of the system databases like the master database. So let's use our master database. Execute. Now we're in the master database, so now we can go ahead and drop our computers database, and I'm just going to execute this. And when we refresh our database, refresh the databases folder, now we only have our system databases, or the database that we created and now deleted. All right, so let me take this moment to quickly say that you are all rock stars and good job. In the last 15 minutes, we've learned about data. We talked about databases and database management systems. Some of you wrote your first SQL query. You created a database, you selected a database, and successfully deleted databases. So that's amazing. Good job. Next, we're going to talk about SQL. So what exactly is SQL? Once we talk about SQL, then we will explore different data types in SQL. Then I will introduce you to tables. SQL is an acronym for Structured Query Language. Now, SQL is sometimes referred to as SQL, and you may have heard me use SQL and SQL interchangeably. SQL is the language used to communicate with a database in a relational database management system. Earlier, we talked about what a database management system is. Relational database management system is one of several types of database management systems, and SQL is the language we use to communicate in a relational database management system. In other words, there are other database management systems that do not use SQL to communicate with a database. To provide you with some clarity, let's consider the image below. We know that we have our database, and inside our database, we store data. We also know that we need our database management system to interact, to manipulate, to retrieve data from our database. In our case, we are using Microsoft SQL Server. So Microsoft SQL Server is the database management system that we are using. However, Microsoft SQL Server is a relational database management system. So Microsoft SQL Server falls under relational database management system. Now, in order for us to communicate with our database, SQL is the language that is used to do that communication. So SQL is that bridge between our data, or between our database and the database management system. I should say relational database management system, because like I said, there are other types of database management systems that are not relational. So when we typed create database, computers, create database, restaurant, that is SQL. When we deleted our database using the drop command, the drop database followed by the name of the database, that is SQL. So SQL is the language that we use to communicate with a database in a relational database management system. It's important to note that Microsoft SQL Server is not the only relational database management system out there. Other popular relational database management systems are Oracle, MySQL, PostgreSQL, and IBM DB2. However, because SQL is a standard, once you learn SQL with Microsoft SQL Server, you pretty much would be able to work with any relational database management system. I haven't said that because each relational database management system wants to distinguish itself. There are slight differences in some of the syntax used to perform certain operations, and they also have a proprietary name for their SQL. Microsoft SQL Server proprietary name is Transact SQL or TSQL. Oracle database is PL SQL. MySQL is simply MySQL. PostgreSQL is PostgreSQL. And IBM DB2 is PL SQL. The key takeaway is this: once you learn SQL, it is easy to work with any database that uses SQL because the main difference is with the features they offer and not the SQL language itself. Next, let's take a look at data types in SQL. Data type is an attribute that specifies the type of data. We have the numeric data type, string data type, and date data type. Under the numeric data type, we have two types of data that can be stored inside of a numeric data type. We have int, which stands for integers, and decimal, which is used to store decimal numbers. We have the string data type varchar, which is used to store character values, but can also accept numeric values. The date data type is used to store date and time values. If we look at the int data type, we can use it to store all numbers. 3, for instance, 9. It takes on both positive and negative values. So minus 54, minus 3. All of these can be stored under the int data type. Decimal data type is used to store values that has decimals, and it can also take on both positive and negative values. 3.5, 0.8, minus 4.2, minus 5.5. When we look at the string data types, the string data type is used to store character values, and this could be words, it could be a letter, it could be words. The varchar, which is variable character, can store between 1 and 8,000 characters. Another important point is that within string data types, we have to insert the values inside of single quotes. Here we have rainbow in single quotes, we have cookies, we have John. Another thing is that with string data types, it can take on both character values and numbers. And all we need to do is to insert the numbers in single quotes. And essentially, even though those are numbers, it becomes a character value. Now, you don't have to think too deeply into all of this that we've talked about so far, because once we start working with these different data types, it would make more sense to you. Also, we can store a negative number within a string data type, because as long as we are able to impute those values inside of single quotes, then we are fine. Next, let's talk about tables in SQL. We know that data is stored inside the database. However, we need to have the stored data in the database organized and well structured. And this is where tables play an important role. The data in our database is contained inside of a table. Let's take a look at this customers table. Each column represents a field and each row represents a unique record. We have the first name column, last name column, the date of birth column, and the customer ID column. Now, each row is a unique record. So we have this row that belongs to Tom Bradley, date of birth January 10, 1995, with a customer ID of 1002. So the information we have in this row is unique to Tom Bradley. We can go down the list. We have Pooja Shah, May 11, 1990, and with a customer ID of 1221. We have Mary Thompson, June 20, 1995, with a customer ID of 2254. So in a table, we have columns, and then we have rows. And each column is also referred to as a field. Now, once we have an information, typically you could look at this as a cell, but it is also a field once an information is inserted inside of that cell. So this is a field, this is a column, this is a row. Earlier on we talked about data types, and we can see how this table is structured with different data types. We have the string data types because this contains character values. So the first name and the last name contains character values, which makes them a string data type. If we look at the date of birth, this contains information about dates. So this is a date data type. If we look at the customer ID, this contains integers or numbers. So 1002, 1221, 2219, 2254. So this is a numeric data type. So having our data inside of a table helps us to achieve structure and efficiency with our data. Okay, so enough of all the talks. Why don't we switch over to SQL Server and write some new queries? The next query I will show you is how to create tables in SQL. But before I do that, I would like you to create a new database because we don't currently have a user-defined database. Earlier on, we created two databases, which we already deleted. So I'd like you to create a new database. The name of the database would be pets. All right, to create a new database, all we need to do is we type create database followed by the name of the database pets. We end with a semicolon, and now we can execute our command. If we refresh the databases folder, we should have our pets database. The syntax to create a table in SQL is we have the keywords create table followed by the name of the table, and then we open up a parenthesis and we have two arguments. First, what is the name of the column that we want in the table? So we write the column name followed by the data type. So essentially we have to indicate what type of data would be in that column. Now, if we want to have multiple columns, then we have a comma to separate the first column, and then we do the same thing to add a second column, which is we write the column name followed by the data type, and then we close the parentheses and end with a semicolon. Let's say we want to create a table that contains information about dogs. Since we intend using our pets database, the first thing we need to do is to switch into the pets database, because as you can see at the top left corner, we're currently in the master database. So we use our use pets command. And when we execute this, now we are in the pets database and we can create our table inside of the pets database. I'll write out the query to create a table, and then we go through the query together. Okay, let's go through this query together. The keywords to create a table is we have create table followed by the name of the table. In our case would be dogs. We open our parentheses And then the first argument is we write the name of the column which we want, which is name because we want to capture the name of the dogs. Now we have to indicate the data type of this column. Because we know the names will be in characters, then that's a string data type. So we write varchar to indicate a string data type. Earlier on I told you that varchar can contain between 1 to 8,000 characters. Now we have to pass the argument as to the total number of characters that we want this name to be. So what we're saying essentially is that the name of our dogs cannot be more than 30 characters. So we pass 30 inside of these parentheses. Because we want a second column, we have a comma. The second column will be the age. We want to capture the age of our dogs. So age will be in numbers, and it will be an integer. At least that's what we want. We want the age to be integers, whole numbers. So we have to indicate the data type, which is int. We close our parentheses, and then we have a semicolon to indicate that we are done with this query. All we need to do now is to execute this query. We can confirm that the dogs table has been created, and to do that, let's click on the pets database, the menu, and if we go to the tables folder, just click on the drop down, we can see that the dogs table we created has now appeared here. All those other tables we see are just system-generated tables that contain information or data for the functioning of SQL Server. Let's create a second table. This time we want to create a table to collect information of cats. Again, I'll write out the queries and we'll go through it together. And we can pull those down. Okay, so let's take a look at the syntax. Again, we have a create table. The name of the table will be cats. We open our parentheses. The first column will be name. The data type is varchar. The maximum characters of the name is 30. We have a comma to separate the first column from the second column. The second column will be age, which is an integer. We have a comma. And now we have a third column, which is color, to capture the color of our cats. Because color will be in characters, then that will be a varchar. And now we also indicate that the maximum length of the color cannot be more than 30. We close our parentheses and then we end with a semicolon. Let's create our table. Execute. And now if we refresh the tables, now we have our cats table. So far we've learned how to create database. We know how to use a database, and now we just learned how to create tables in SQL. I'm sure you'd agree with me that there's not much you can do with an empty table. So how do we insert records into a table? And that's what we're going to try our hands on right now. Let's take a look at the syntax to insert records into a table. We have the keyword insert into, followed by the name of the table. We open our parentheses, and we have to indicate which column we want to insert records into, or insert values into. So we have column 1, and then we have column 2. If we have multiple columns, if we have more than 2 columns and we want to insert records into all of those, we have to indicate that here as well. We close our parentheses, and then we have the keyword values, which is really what value do you want to insert into those columns. So assuming that this is a string value, we have to input that in parentheses, or in single quotes. We have a comma, we have the second value, we close our parentheses, and we end with a semicolon. Let's insert some records into our docs table. To do that, we have the keywords insert into, followed by the name of the table, which is docs. We have two columns we want to insert records into. In parentheses, we indicate those two columns. We have the name column. We have a comma to separate the name column from age. We close our parentheses. And what are the values we want to insert into these columns? We want to insert the name Bella, so that will be the name of our first dog. Because Bella is a string character, or because this is a string character, we have to impute this in single quotes. We have a comma, and then we have 4, which is an integer. For integers, we don't have to include or embed that in quotes. In quotes. We close our parentheses, and we end with a semicolon. To insert records into cats, we have insert into cats. We have the name, we have the age, we have the color, all separated by comma in parentheses. The values we want to insert, we have Cindy, which is the name. Cindy's age is 5, and Cindy's color is brown. Let's switch over to SQL Server and write out this query. Just gonna scroll down a little bit. Okay. So I'll write out the query first and we'll go through it together. Okay, so we have insert into docs, the name, the age, and the values will be Bella in quotes, and then the age will be 4. Execute. We see the result says 1 row affected because we really only inserted 1 row of record, and it gives us the completion time. Let's insert some records into the cats table. All right. And now we have, again, for our cats table, we have the name, the age, the color, and the values will be Cindy will be the name in quotes because it's a character string data type. We have the int, the age is 5, and then we have the color, which is brown. Let's go ahead and execute this query, and that's been executed. So far, we know how to insert single records into our tables. What if we want to insert multiple records at the same time? That's also very possible. To do that, I will copy, let's insert some records into the docs table. And I'm just going to copy, so you could just copy the same query. I'm going to paste. And now, because we're really just using the same query, all we need to change is the values. So to insert another record, let's say the name, let's say the dog's name is Tom. And let's say Tom's age is 6. Now, to insert multiple records, all we need to do is separate the first record with a comma, and now we can open our parentheses and insert another record. Let's say the second dog's name is Woofy. So we have that in quotes, and Woofy's age is 5. And now we can close there. If we want to insert, let's say we want to insert 3 records at the same time, we separate with a comma, we open our parentheses, and let's say the name of the third dog is, let's say Poggy. We close our quotes, and now Poggy's age is 4. Now we can close this and end with a semicolon to indicate that we're done with this query. Go ahead and execute. Now we see 3 rows affected because we just entered or inserted 3 different records. So far, we created 2 tables. We have the dogs table and the cats table, and we have successfully entered some records into both tables. The question is, how do we retrieve those records from both tables? The syntax to retrieve records from a table is, we have the keywords select followed by star, from, and the table name. So if we want to retrieve records from the cats table, we have select star from cats. From the dogs table, we have select star from dogs. The select statement really means that we're telling SQL Server to retrieve all, or well, to retrieve, the star there means all. So we're saying retrieve all the records from the cats table. Give me all of the records you have from the dogs table. So we type select star from dogs. Okay, so let's take a look and see what this looks like. Select star from dogs. And now we execute. And now we can see the dogs table we created. We have the two columns, the name column, followed by the age column. We have Bella, age 4, Tom, age 6, Wolfie, age 5, and Poggy, age 4. The numbers we see here are the row numbers to indicate the number of rows we have. Let's print out the cats table. Select star from cats. Execute. And now we have the cats table we created with the records. We have name, Cindy, Cindy's age is 5, and Cindy is a brown cat. You can see how easy it is to create databases, to create a table, to insert records into a table, and also retrieve records from a table. What if we choose to delete our tables? Let's pretend that Cindy has been adopted, and our dogs, let's print out the dogs table. Bella, Tom, Wolfie, Poggy, all of our dogs, they've all been adopted, and we really don't see a need to keep the business. We just want to travel around the world and not worry about anything. We've made enough money. How do we delete the tables that we created? The syntax to delete a table is simply we type the keywords drop table followed by the name of the table. So if we choose to delete our cats table, all we need to do is type drop table cats. We end with a semicolon. Let's go ahead and delete our dogs table. And of course, we are sorry to see Bella, Tom, Wolf, and Poggy go, but they're going to a nice family. We're rest assured there's nothing to worry about, so we're fine deleting them from our database. So to delete this table, all we need to do is we type the keyword drop table dogs. And now we can execute commands completed successfully. Note that we still see our dogs table showing up here, but if we refresh the tables, now we see that we don't have the dogs table anymore. Let's print out our cats table. We select all from cats. We execute. Now we have Cindy, that's the last pet to be adopted, and now we can go ahead and delete this table as well. And again, we are sorry to see Cindy go, but Cindy is going to an amazing family. Execute, that's completed. When we refresh this, our cats table has been deleted. Before we move further, I would like to quickly show you how to add comments within our SQL commands or our queries. Because if we look at it so far, we've actually done quite a lot. We created a database, created a table, inserted records, and deleted our table as well. And it's always good to, for different reasons, we might want to make different comments. So for example, we might want to say, how to create a table, just as a comment to separate these lines of codes. Right here, we might want to say, inserting records into our table. So writing or having comments within your queries is a very common thing. It is also possible that when you write your SQL commands or your queries, perhaps someone else might need to see that query. And by adding comments, you can use the comment to indicate what the query is all about or what you're trying to achieve with a particular set of queries. So the way to insert, and there are multiple ways in which you can insert comments within SQL, within your queries, but I'll show you the single line comment. And to do that, all you need to do is So I'm going to start from here. Let's say we want to insert, and I'm just pressing the enter key right here. Let's say we want to insert a comment here that says deleting our table. So first I'm just going to write it out. So deleting the dogs table. And right now you can see all of this is red, and this wavy line is sort of indicating that there's a trouble with this query. And that's because SQL is thinking all of this is some sort of query, what is one query, right? But that's not really it. So to make this a comment, all we need to do is you just type dash twice, and that's on most keyboard, that should be the key after 0, the number 0. So all you need to do is just press dash twice, and immediately you see that this goes green. And whatever we do now, it's not going to affect this query. Right now we can't run this query again because there's really no dogs table. And let's actually try and do that. And I'm going to run this with the comment. And when I execute, it says cannot drop the table dogs because it does not exist, or you do not have permission. Essentially, it's just saying there is no dogs table, and we know that because we deleted that already. But why don't we go to where we created this dogs table, and let's add another comment, and let's say creating our first table, right? So let's actually create this table again. So I'm going to run this with the comment, and when we do this, we can see that it says commands completed successfully, because what happens is that this comment is now totally ignored even when we run this query. But by adding this comment, we're sort of indicating a step, of what we're trying to do. So now we have our docs table again, and if we select all, we can see, okay, well, right now it's just showing, it shows the columns, but we've not inserted any records, right? So let's insert and I'm gonna make a comment here as well. Let's say inserting records into our table. Okay. And now let's insert this record into the docs table. And if we scroll further down, let's select our docs table, and now we have Bella H4. So now we can go ahead and drop this table again, and I selected or highlighted both the query and the comment, and we can see that it's completed successfully without any issues. Okay, so I'm not sure if you know this, but just in case you don't, although I believe you do, you are amazing, and I'm not even joking. In less than an hour, you have come a long way. You've learned a lot, and I'm not gonna list everything you've learned, but if you're to take stock, this is a lot of information, and you're still here. So I would say thank you, good job, and you are amazing. So I'm thinking maybe we can add another 30 minutes of coding skills to your SQL toolbox. That way you can walk out of this session like a pro and feeling pumped. What do you think? We're good, right? All right, let's do this. Just another half an hour and you're good to go. Let's talk a little bit about SQL Commands Categorization and the different commands that falls under these categories. SQL commands are grouped into three main categories. We have data definition language, DDL, data query language, DQL, and data manipulation language, DML. Now, these are not all of the different categories that we have, but most of your SQL commands will fall under these three main categories. Data definition language are SQL commands that are used to create and modify the structure of a database object. We have the create command, which is used to create database and its objects. By the way, when we talk about objects, objects in SQL really just means anything that points towards a data or towards data. So a table, for instance, is an SQL object. So If you remember earlier on, we used the create command to create a database. We also used it to create a table. We also have the drop command, which we used already. When we dropped a database, we used the drop database to drop one of our databases, and we also used it to drop our tables. So already we have covered both the create and the drop command. The last command under the data definition language is alter, which we use to alter the structure of a database. Assuming we need to add a new column to an existing table, so we want to alter the structure of that table. The syntax to do that is we have the keywords alter table followed by the name of the table. And since we want to add a new column, we have the keyword add, and then we have the name of the column that we want to add, the new column, followed by the data type of that column. Let's switch over to SQL Server and see what this looks like. So we already deleted our docs table, but not to worry because we can just run the query again to create that table. So we have the docs table has been created. Let's insert this record into the docs table. You know what? Let's actually insert this record because we have 3 records here. Let's insert these 3 records into our docs table. And now let's print out our docs table. Select star from dogs, and this will print out all the records. So now we have these 2 columns, the name column, and we have the age column. We have Tom, 6 years, Wolfie is 5 years old, and Poggy is 4 years old. Now we have this table, assuming we need to add another column. Let's say we want to add a record of the colors of our dogs. The way this table is structured, we can't go back because this dogs table has been created already. And I'm just going to I'm going to copy this query. I'm just going to copy and I'm going to paste it right here. So because this dogs table has been created, we can't just go and add a comma here and then say color. I'm just going to write color and varchar, let's say it's varchar 30, right? So if we try, and let's run this query, if we do this, it's going to tell us that there is already an object named dog. So it's really just telling us that we already have a table named dog. So we can't just go back to the schema that we created before and add a color column to that schema. That won't work. So the way to add another column, in this case we want to add a color column, would be to use the alter statement. Okay, I'm going to delete this because we don't need this. We don't need that there. But let's print out our dogs table again. So just going to go select all from dogs. Okay, so we have our dogs table, we have the name and the age, and all we want to do now is to add a new column, and the name of the column would be color. Okay, I'm going to write out the query first and we'll go through it together. Okay, so let's go through this alter command. We're trying to add a new column, and this should be dogs. We're trying to add a new column to the dogs table. Okay, so the command is we type alter table followed by the name of the table we want to alter, which is the dogs table. Okay, now we drop down and we have to tab and the reason we're tabbing is because this query depends on this alter table command. So we kind of put it in a block of code. So we tab and then we type add, and what's the name of the new column we want to add? That's the we want to add a color column. What's the data type? So we include, because we know color would be, it's going to be a character. The values will be text or characters, if you will. So that's a string data type, and we know we use varchar 4 string data types, right? So we have varchar, and then in parentheses, we include the total length of what the color can be. Well, I don't think there's any color that's up to 30 in the first place. You know, most colors might be under 10, but who knows? But we're setting it that the maximum name that falls under this color column should not be more than 30 characters. So now we can go ahead and execute. Commands completed successfully. And now when we print our docs table, we can see that we have a new column, which is the color. And we see that it says null, and this is because there are no values. We have not entered any values, like we didn't enter any color value for Tom, Wolfie, or Poggy, right? But we have achieved what we wanted to do, which is to add or insert a new column into our docs table. Let's go ahead and insert a new record into the docs table. All right, so we have our insert query. So we're inserting into the docs table. The columns we want to insert values into is we have the name, we have age, and we have color. The values for the name, so the dog name we want to insert is Sean. The age is 3, and the color is gray. Let's execute. 1 row affected. And now when we print out our docs table, we can see that a new dog has been inserted. We have Sean, age 3, and color gray. And I'm just going to add a comment right here, and let's say making changes to the structure of our table. All right, so that's how we alter a table. What if we want to make another change to the structure of the table? Let's say we want to drop, or let's say we want to delete the age column. How do we do that? So we use the same alter statement, alter. What do we want to alter? We want to alter the dogs table. And this time, because we are deleting a column, we type drop column. And what's the name of the column we want to delete? And that's the age column. Now we can execute, and if we now print out our docs table, we don't have the age column anymore. The next topic I'd like us to talk about is SQL constraints. Constraints are rules we enforce on our table to specify the types of data that can be stored in our table. Also, constraints can be applied on either the column level or the table level. So essentially, we can either pass a constraint on a column, enforce a constraint on a column, or we can enforce the constraint on the table as a whole. One of the constraints we have in SQL is null and not null. Null means unknown or missing value, so it's not the same as 0 or blank. Now, earlier on, and let's switch back to SQL Server. If we look at our dogs table, we have this field that says null. So essentially, we have null values for the color for Tom, Wolfie, and Poggy. Now, this does not mean that Tom, Wolfie, and Poggy don't have a color. It's just that we don't know, or we did not impute that record. And for us, we know maybe it's because we altered our table and added a color column, and at the time we didn't add values for Tom, Wolfie, and Poggy. And later on, we added values for Sean, and we added a color, right? But essentially, this null values doesn't mean no, it doesn't mean nothing or 0. It's just that we've not inserted any record, or we don't know what that record or what that value is. It doesn't mean Tom is colorless or Wolfie is colorless, right? So what if we want to enforce that whenever records are entered into our table, into our docs table, we want to ensure that a value is entered for the color of the dogs. So we want to pass a constraint on the color column to say that when customers enter maybe into a form, when they bring in their pets, we want to make sure that we have the name of the pet, we want to have the color of the pet, and maybe the breed of the pet, right? So we want to enforce that this field is compulsory and a value has to be inserted. To give you a more practical example, you probably have had to fill out a form that looks like this, either when registering for a particular service or you're buying a product. Visually, we know that the red asterisk is implying that that is a mandatory field. You have to enter some sort of values into those fields. But for us, as the owner or the service provider, we have to ensure that on the back end, we enforce that rule. Think about it this way. If you're registering for, say, a gym membership, one of the ways we need to confirm your registration is perhaps we have to send you an email. So it means we need your email. Maybe we definitely need your first name, we need your last name, we need a username for you to log into maybe your online gym membership profile, whatever the case may be. Of course, you also need a password. But for us, we need on the back end to enforce this rule. Otherwise, some people may choose not to enter maybe their email or a name that we need to provide the service for them. So how do we enforce this? On the back end, the service provider or this company would have a database that has been created to store the information of the customers. And that's really what we've done so far. We've been able to create a dog's table, a cat's table, and that's really it. There is a database that collects all that information. The table would have also been created in this form. So we have a table, the name of the table would be customers. We have the username that the customer has to create, a password, the first name, the last name, the email, the telephone number. And what happens is that now you go to this website to enter all of this information as this form requires. So you enter your username, which is really just an insert command, which we have done. Of course, you're not the one on the front end writing this queries or this code. What happens is that on the back end, these queries would have been pre-written, and there will be an application that really just, if you will, extract the information you enter into the form and extract that and put it into this pre-made codes and then insert the values into the table, which is in the database. But when we create our schema, just the way we have, the schema that we see right here, the table schema, there's nothing really enforcing and ensuring that the client or the customer must input values into any of this field that we've indicated. So let's take a look at how we enforce that on the back end. Okay. So I have the schema that I have copied, and this is just to create a customers table. Let's quickly go through it. So we have the create table. The name of the table is customers. The first column is the username, which will be varchar. 20 will be the maximum characters of the username that the customers can create. We have the password. The maximum is 20 as well, which is varchar. The first name will be varchar 50. Last name varchar 50. And the email will be varchar 50 as well. And we have another column, which is the telephone number, which would be an integer. We close our parentheses and we add with a semicolon. So I'm going to go ahead and execute. So let's print out, let's just see the table, select all from customers. And let's run this. So right now we just have the columns. We have not inserted any value, which is fine. We will do that now. So to point to what I was talking about earlier, assuming we have our form or we have this website, we're collecting information for gym membership, and right now the way the schema is, there is no constraint. So let's try and do that. Let's say we only want to insert the first name and the last name. So let's insert some records into our table. and then we want to insert. So what we want is we want to actually collect all of this information, right? That's what we want as the service provider. But let's say a customer, they go to the registration page and all they insert, because right now they're typing in their information, right? And all they choose to insert is the name, which is the first name. And they also insert the last name, right? And now we have values as, let's say the first name is Alex, and let's say the last name is Martins, and that's all the customer choose to provide. When we execute, and now let's print out our table, and we can see that that works. So the customer is able to decide not to enter a username, a password, an email, or telephone number, which doesn't really help us because we need at least the email and maybe the telephone number, some sort of contact. Once the customer register, we need to notify them, and we need to have records for our own purposes as well, right? So how do we enforce that when a customer goes on our website to register, that they have to input a username, a password, maybe the first name and the last name and the email as well? And this is where the null constraints comes to pass. So we want to pass a null constraint, okay? So to do that, the first thing I would like us to do, because I want us to use the same schema, but let's drop that, let's delete that table. So drop table, customers, and execute, right? So that's done. And now let's just copy the schema again. I'm going to paste it right here, and all we need to do is, if we want the username to be compulsory, so we don't want this column to be null, right? So all we need to do is, after the data type, we just need to type not null, and this is just indicating, this is telling, by this way enforcing the constraint that this value cannot be null. The password as well, we say not null, and then for the first name, because we'll need the name, not null, and let's say we want the last name to be compulsory as well, not null, and we need the email as well, not null, and let's say we're fine with them not including the telephone number, right? So now let's create a schema, execute. Now let's try and do what we did earlier, which was to just insert the first name and the last name without other values. So let's just execute, and immediately we can see there is an error message which says cannot insert the value null into the column username. So it's saying that we have to insert a value into username, right? Now you as a customer would not see this, when you're trying to, and you've probably observed this in the past. You put in an information, and then you get a pop-up message that's that shows you that you've missed a particular field, and there is another application that then displays something else. It's not going to show all these jargons because that won't make any sense to a user. So there will be an application that on the front end just shows, oh, you've missed this, enter a username or enter a password or retype your password, something like that, right? But by doing this now, we have enforced that constraint that when a user go to our website, they have to enter all of those values. So now let's enter a proper value into this field. So I have a query already, an insert query. And so this is going to insert values into username, password, first name, last name, and email. And you know what? Let's just exclude the telephone number since that's not compulsory, just to show you that it will work because we did not pass the not null constraint on the telephone number. So I will take this away as well. And now let's execute when we're affected. And if we print out our table, so select all from customers and execute. Now we have our table, the username, the password, the first name, the last name, the email, and then we don't have any value for the telephone number, which is fine because we are fine with the customer not imputing their telephone number. So this is how we pass a not null constraint on a column within our table. And I'm just going to make a comment right here, and we'll just call this the null constraint. Okay. Let's take a look at one more constraint. We also have the default constraint, which is used to display a specified value when the insert into statement does not provide a value. To explain the way default constraint works, let's assume that we need to collect voters' information in the state of Florida. And we only need basic information, maybe just the first name and the last name of the voters. But we also have a column that shows or captures the name of the state, which in our case is Florida. Now, because we know all the voters will be in Florida, perhaps we're fine if the voters don't enter that information, but we want to still display that information. Let's switch over to SQL Server, and this would make more sense. Okay, I'm going to make a comment, and we'll call this default constraint. All right, so what I'd like us to do is to create a new table, and we will call the table voters. So create table voters, and we like to have the first name of the voters. This will be varchar, and we'll make it varchar 50. We will also want to have the last name of the voters. We have that as varchar, and we'll make that varchar 50 as well. Now, let's say we have a third column which captures the city of our voters. Okay, so we'll say city, and this will be varchar as well, and we'll make it varchar 50. Okay. But we want to make this field optional, so we're fine if the voters don't enter this information, but we still want to print out the name of that city. Now we can use a default constraint to say that if the voters do not enter a value into this column, I want you to print out a specific value. And to do that, all we need to do is we type the default. And what's the default value that we want? It will be, let's say London, okay? So that's the default value that we want. So this is saying that for the city, I want you to print out a default value of London. Now, if and we have to close the parentheses there. Now, if the voters do enter a value, it's going to show that value, but if they don't enter a value, then print out London. Let's create this table, and now let's just insert some records. So let's insert this record, execute, and now let's print out our table. Select all from voters and execute. So what we see here is that even though we did not enter a value into the city, we have a default value printed out. Now, assuming, and let's copy this query again. And I'm just going to paste. Now, assuming that the voter decided to enter the city, and let's say we're going to add the city into the insert query. Now, and I'm just going to delete this because I just want to enter one record. So let's say we have another voter that for some reason is from another city. I'm not sure how that happened, but let's pretend this voter is from actually a different country, like France, right? Now let's enter this record, And you know what? Let's add an object. No, that's fine. So let's enter this execute, and now let's print out our table. So we can see that because the user entered a value of France into the city, that overrides the default value of London that we set when we created the schema for our table. So the way the default constraint works is that if a value is entered into that field, then that value is displayed. But if a value is not entered, then we have a default value that is displayed or entered into that field. I'd like to take this moment to say a big congratulations to you. From knowing little or nothing about SQL, you now have a solid foundation which you can build on. You really should celebrate this moment. The next topic really is to give you some tips regarding transitioning into a data-related field. In my experience, most people who choose to learn SQL do so because they intend going into the data world. I'd like to know why you decided to learn SQL. Kindly drop a message in the chat on what prompted you to learn SQL. I'm sure I'm not the only one that I've seen ads on different social media platforms with taglines claiming a fast turnaround from knowing nothing about a specific discipline to getting a job in that field. So you see ads like become a data scientist or a data analyst in 3 months. Now, is it possible to learn the core skills required in that field or in a specific field within 3 months? Maybe. But in my opinion, it takes time to learn the core requirements, then apply for jobs, go through multiple interviews before eventually getting a job. Perhaps you are wondering, how long does it realistically take to make that switch? And my response is, it depends. I can tell you it took me about 8 months to learn the core requirements, did a bunch of interviews that didn't go well, and eventually I got a position. Now, I said all of this so you don't get frustrated as you embark on this amazing and rewarding journey. Another thing you should know is that the IT space is fast moving. Things get obsolete quickly and there's always a need to evolve, otherwise you get left behind. Which means if your goal is to remain in this field for a long time, then you need to be open to the idea of always learning. The good news is rarely would you be starting from the beginning because changes are usually an upgrade or a better way of doing things, which is really a build up from what you already know or what already exists. The next tip I would like to give you is you need to know the general job requirement for the field you're going into. So you are taking the bold step to learn SQL, which is great. However, if your goal is to work in a data-related field, you would need to know more than SQL. Rarely would you see a post that only requires SQL knowledge. Usually you would have some combination of SQL, Python, R, or Excel. Now, there is also the expectation for data professionals to create visualizations of their data analysis, which means you would also see job posts requiring knowledge of either Tableau or Power BI. My recommendation is that you learn at least 2 of the core data analytics applications, so for example, SQL and Python, and then you can easily pick up Excel on YouTube and learn one of the data visualization applications, so either Power BI or Tableau, and PowerPoint is also a good one. Next, your first job may not be exactly what you're looking for, but first, all you really need is getting into the field. Once you're in the field, it becomes easier, and over time, you will get what you want. For example, maybe your ideal job would be to become a data scientist, right? Your first job may end up being a BI analyst. And that is fine because usually once you are on the job, you will be interacting with teams and with people with different skill sets and different professionals, which gives you a better understanding of what they do. So you may be on a team that is involved with different projects. And for that project, you might have data scientists as part of the project. You might have business analysts. You might have ETL specialist, quality analyst, a bunch of different people with different skill set. And what this affords you is now you get a view into what they do on a daily basis, and that's going to help in terms of building your capability and switching to that role if that's one of the roles you're looking for. Another thing is that you can't always judge a job post by the job title. What company A calls data scientist may be what company B calls data analyst. So it really boils down to what you're doing on the job. Perhaps you are asking yourself the question, where do I go from here? Certainly you have learned quite a lot today, and you may be wondering if this is all you need to know. The good news is, with what you have learned today, you have a good, solid foundation, and I can take you from this level to becoming an expert in SQL. With an investment of $29.99 in yourself, you can enroll in my SQL Beginner to Advanced level course. In a moment, I will go through the course content. Because I want to be a part of your journey of successfully transitioning into the data analytics world, just like I did, if you register for the SQL Beginner to Advanced level course today, I will give you free access to my Python for Data Analysis Beginner to Advanced level course. Some minutes ago, I shared with you the core job requirement of data-related jobs being SQL, Python, Excel, R, and also learning either Tableau or Power BI for the data visualization piece. With only $29.99, you can have access to two of the most important skills you need to excel in this field. Let's quickly go through the course content. The first section is just introductory into the course itself, and this is where we do most of our downloads, application downloads and installation. If you have installed SQL already, you would be saving yourself some of this process. The second section deals with data, databases, and database management systems. Some of these we covered in today's workshop, but there are a few details that wasn't covered. In the third section, we dive into SQL, so introductory to SQL. Part of this we also covered today. Section 4 talks about data types. We also covered the numeric and string data type in today's workshop, but we will be diving more into the date and time data type as well. Section 5 is about tables, how we create tables, and again, we did review some of this today, but I believe we did not work with deleting tables, so we will be learning that in this section. Then we dive into data definition language, DDL. We covered some of this as well today, but we will even go further and talk about primary keys and unique constraints within the section. Section 7 is data query language, DQL. We will explore the select and where clause. Section 8, data manipulation language, and this we will work with the update, delete, add in aliases, decimal data type as well. In section 9, we dive into the world of string functions and learn the commonly used string functions in SQL. Section 10 will get into exploring our data by sorting records. So we'll look at different commands to sort records in SQL. In section 11, we dive into the world of aggregate functions. We learn how to group values based on certain condition and then perform an aggregate function on the unique groupings. Section 12 is all about date and time data type. So we'd spend a lot of time actually learning about date and time data type. Then section 13, we dive into comparison operators. Section 14 will be logical operators. For section 15, we dive into data relationships. And this is definitely not a couple therapy. This is exploring the ways data are related, especially when we have to join data from different sources. So we will learn a lot about data relationships. We'll look at creating one-to-many relationship, which is one of the types of ways data could be related. Then we'll look at many-to-many data relationships. And then we have a lot of tasks in creating many-to-many relationships. And then we have the conclusion. This course is designed to take you through that pathway of where you are right now to become highly proficient and an expert querying in SQL. As mentioned earlier, when you register for the SQL Beginner to Advanced level course, you also get free access to my Python for data analysis course. Let's quickly go through the content of the Python course. For the Python course, we also have the first section, which is introduction. And this is where, again, we do all the necessary downloads and installation of the application we need to learn Python. Then we dive into data types and variables in Python. And I'm not going to spend a lot of time in reviewing this course content, especially if you don't have prior knowledge of Python. All of this may not make absolute sense to you, but you can be rest assured that this is also built to take you from zero to hero, from knowing nothing about Python to becoming an expert analyzing data using Python. Section 4 is using strings in Python, so we'll learn different string methods. Section 5, we dive into slicing, format function, and casting. In section 6, we look at the list data structure, and we look at some of the methods on the list. Then section 7 is control flow. We will also work on a project, and by the way, there are actually 3 projects, mini projects within the Python course. So we will be working on a project at section 7. Section 8, we look at tuple data structure. Section 9, dictionaries. Section 10, we'll look at some of the Python built-in functions, and we'll also look at how we can build our own functions in Python. Section 11, we look at series, and this is where we dive into data analysis. We dive into the pandas, Python pandas library, and this is the core application for data analysis in Python. So we're going to review series, and then we get into data frame, and we have 3 separate sections dedicated to data frame. And then we go into manipulating text data in a data frame. Then section 16 is multi-index in data frame. So we will learn how to perform multi-index functions in a data frame. In section 17, we'll learn about the group by object, and we'll be looking at different methods in that. And then we also have data relationship, which we will explore. We'll look at the different joins, inner join, left join, right join, and outer join. And in section 19, we will dive into date and times data sets. And then we would look at some other ways of importing and exporting data sets from Python. And then we have the conclusion. Once you register for the course, you have lifetime access to the course materials. You will also receive a certificate on completing the course, which is very valuable. I know people who have gotten jobs based on their Udemy certification. You also have access to me through your Udemy account, and you get discounted pricing on new courses. At the moment, I'm actually working on a Power BI course as well. So once that is available, you will get discounted pricing to that course. To enroll for the SQL Beginner to Advanced Level course, you can find the registration link with discounted pricing in the workshop video description. I also have the link posted in the chat, and I'll also send you an email with the registration link. Once you register for the course, I will send you within 24 to 48 hours access to the Python for Data Analysis course. Now remember, to receive the free Python course, you do need to register for the SQL Beginner to Advanced Level course today. If you have any questions regarding registering for the course, or for some reason you're unable to register today and still want to take advantage of this offer, send me an email to techquesthub@gmail.com and I'll be happy to chat with you. If you're still considering why you should sign up for this course, first I would say the same reason almost 6,000 students are enrolled in my courses and rating my courses high because of the relevant content and my practical on-the-job approach to teaching. You may also be thinking, why pay to learn SQL and Python when I can learn SQL and Python free from YouTube? My response to that would be, quite frankly, you are getting these courses practically free. I teach the same course for hundreds of dollars in person and on other platforms. Also, yes, you are correct. You can pretty much learn anything on YouTube. The difference is you are not just learning anything when you register for this course. You are guided on a path towards your dream job. Learning the core requirements rather than being lost, confused, and not having a structure. The course content is based on my personal experience from interviewing for jobs to getting into the field and being on the job and now knowing what is expected when you work with SQL or Python. Finally, I would like to say a big thank you for joining today's workshop. I hope you had an amazing time. I certainly did. You can leave some feedbacks in the chat, and I will also like to encourage you to keep your dreams alive. You are one step closer to fulfilling your goals, and I will see you at the top.